So the last section of chapter 9 is about finding area when you have more than one polar curve. One possibility when you have more than one polar curve is that one of your curves is farther away from the origin than the other. So like here's an example in this picture. I'm going to look for the area that is outside of the cardioid and inside of the circle. So I'm looking for, this would be the area that's inside the circle from where they cross. And then I don't want the area that's inside of the cardioid, so I would subtract that away and be left with just this kind of moon-shaped region. As I'm sweeping out from the origin, when I do this, I am hitting the red curve first consistently. So as I go through my rays from the origin, I'm always hitting the red one first. And so these are curves where one of the curves is farther away than the other. And when that's happening, in that case, we're trying to find the area between those two curves. We find the intersection points and we do the area formula subtracted. The area formula for polar has a squared in it, so that's why these are squared and then subtracted, because that's the area formula for polar. It's not the same thing to subtract and then square. All right, so here's an example. We want to write an integral for the area inside 8 sine theta and outside r equals 4. So first of all, let's figure out where they intersect. That's an important thing to know. So we're going to set them to equal to each other so we can figure out where they intersect. So 8 sine theta equals 4. So that would mean that sine theta equals 1/2. And that's going to happen at theta equals, well, pi over 6. And 5 pi over 6 would be another place where they intersect, because then sine would be positive 1/2. And that's it on the unit circle. All right, so now let's kind of make a picture. R equals 4 is easier to graph. That just means no matter what theta is, the radius is always going to be 4. So we have a circle with a radius of 4 centered at the origin. And then 8 sine theta, we can do a little table of values if we're not sure what that looks like already. So we could say, well, if theta is equal to 0, r would be 0, because 8 times sine theta would be 0. If theta is equal to, well, pi over 6, we know that r would be 4. If theta is equal to pi over 3, we know that it would be root 3 over 2 times 8. So 4 root 3. I don't know, root 3 is like 1.5, let's say. So this would be about 6-ish. I don't know. So anyway, that's not a great value. Let's try pi over 2. That would be 8. So it's looking like this is also a circle. And if you're not sure, you can plug in some numbers, and you would generally have a calculator for the polar question on the free response anyway. This is our intersection point, though I didn't graph that very well. All right. Doesn't really look like a circle the way I graphed it, but it is. And then if I want to set up the integral for the area that's inside, I'm going to go from pi over 6 to 5 pi over 6. And I'm going to use the area formula for polar, so it's going to be 1/2. And as I sweep out from the origin, the 8 sine theta is farther away consistently, so I'm going to do 8 sine theta squared minus the one that's closer is 4, so 4 squared is 16. And then this integral would give me the area. I wouldn't expect you to calculate that integral without a calculator, but I would expect you to be able to calculate that with a calculator if need be. The other day I asked you to make some polar artwork, so here's some examples of artwork that people submitted for that ABA. All right, so this next example, I'm trying to find the integral for the area inside both r sine theta and 9 sine theta and r equals 9 cosine theta. So it's the area that is like the common area of the Venn diagram. I wanted to have this example in here because it's a little different from the last example where there was an inside radius and an outside radius. These two regions are side by side. So I would first find the area of that red region, which is going to be surrounded by just the 9 sine theta curve. And then I would find the area of the blue region, which would be surrounded by the 9 cosine theta curve. So instead of subtracting this time, I'm going to just add those two areas together. First, I want to figure out where they cross. So they cross when the two curves are equal to each other. 9 sine theta equals 9 cosine theta. So sine theta equals cosine theta. They're going to cross at pi over 4. And so then I'm going to do from 0 to pi over 4. And I'm just going to use the sine curve. And then I'm going to add the integral from pi over 4 until the cosine gets back to 0, so pi over 2. Okay. So we have to be thinking as we're setting these up about whether we're subtracting two integrals or whether we're going to add two regions together to get our total area. Our last example, I would encourage you to try it before you finish playing the rest of the video, but we're going to try to find the area that's inside the 1 plus sine theta and outside r equals 1. So the first thing I'm going to do is set them equal to each other. So they intersect at theta equals 0 and pi, which really fits the graph that I'm looking at here. And as I'm sweeping out from the origin, it looks to me like we have a situation here where we have an outer curve and an inner curve. So this time is a subtraction one. So we're going to do the integral from 0 to pi. And we're going to go from, we're going to have a 1/2. And we'll do the outside radius, which is 1 plus sine theta. And then we'll subtract the inside radius, which is 1 squared is still 1. This time it says find the area, so this time we would be allowed to grab a calculator, so I'm going to go ahead and do that. I get, when I type that into my calculator, I get 2.785. I want to really emphasize that even though I used a theta when I entered this, I could have used an x. It would still give me the correct answer if I use an x. The theta is just a dummy variable because the answer is just the area, so we would get that no matter what variable we use. So we have 2.785. All right, so that's the area when you have more than one curve involved. Good luck, have fun.